All right, we're back again talking about complex zeros. Yes, we are still in section 2.5 because there's just that much stuff in it. All right, so the gist of what I need to talk about in this video is this sentence right here. Complex zeros always occur in conjugate pairs. Complex zeros always occur in conjugate pairs. That means that if they give you one complex zero, you automatically know that you have a second and you know exactly what it is. All right, so do you remember what complex conjugates are? Well, if 3i is 1, negative 3i is the conjugate. If 4 plus 5i is one of them, 4 minus 5i is the conjugate. All right, so anytime they give you a complex zero, they've essentially given you 2 for the price of 1. Now it's just a matter of what we're going to do with it. Okay, synthetic division with complex numbers is a real pain. For that reason, I prefer to use the following technique to get my zeros. Now, you don't have to do this. If you want to do complex synthetic division, be my guest. But I multiply the conjugate pair, and then I divide using long division to find the rest of it. I think that's easier than doing synthetic division with complex numbers. All right, so let's say that I was given the following polynomial, and they tell me that 3i is a factor. Well, if I know 3i is a factor, I know that negative 3i is a factor, so I can multiply these two binomials, and it's going to give me x squared plus 9. Now I'm going to synthetically divide this by that so that I get the rest of the factorization. Okay, here we go. Synthetic division. All right, now if it comes out to something other than 0, then something went wrong. Then either you're looking at two different problems to get your information and mixing things up, or maybe this product that you got is incorrect. But if in fact they gave you a 0, then this is always going to come out without a remainder. All right, and now what I'm left with is this, and that I know how to factor. Or do I? Nope, I don't. Gosh, man, I'm making lots of mistakes here. Okay, it's not factorable because the plus on the 6 means they both have to be the same sign. So that means I'm going to need to use the quadratic formula. And in doing so, I end up with a complex number. So all of the zeros of this happen to be complex. Remember, I had 3i, that's what they gave me. So that means I knew that negative 3i was a 0. And now I have this hideous looking 1/2 plus or minus I squared of 23 over 2. But I found them all. All right, let's try something. No, let's not try anymore. Let's do this. Knowing that complex zeros come in conjugate pairs, it's a pain to have to multiply two trinomials when you are given the 0 of a plus bi. All right, because then you have x minus a plus bi, x minus a minus bi, and then you have 1, 2, 3, 4, 5, 6, 7, 8, 9 things to multiply. So I introduced to you a shortcut. If you are given the complex zero in the form a plus bi, the product can be found by using this. Okay, you're going to take 2 times the a times x, and then you're going to square the a and the b to get your third term, which is just a number. So let's see it in action. All right, let's say I have the complex 0, 2 minus 3i. Okay, in this case, my a is 2, my b is negative 3. So I plug it into this formula. By the way, negative 3 when you square it is positive anyways. So it doesn't really matter if you add or subtract that. So we have x squared minus 4x plus 13. All right, that complex shortcut is gonna help you out. It's gonna save you a little bit of time, which is why I called it a shortcut. Imagine that. All right, try this one. You may want to use that shortcut that I just gave you. I want you to try this one on your own. Okay, because I give you one of the complex zeros. All right, here we go. Putting it in the shortcut, we're going to end up with x squared minus 8x plus 17. Now I need to long divide. And it looks like this. First multiply by x to get x cubed. Now I need to multiply by a negative 3. Comes out to 0. Remember, if it doesn't come out to 0, something went wrong. And so now I see what my last factor is. My last factor is x minus 3. And there is the complete factorization. All right, that's it for this one.